For a long time, the story of the human genus was told as if it began with creatures already resembling us in form and behavior. That view no longer holds. Fossil evidence gathered over the last several decades reveals a far more complex and fragmented beginning. Between approximately 2.4 and 1.6 million years ago, a small, agile hominin appeared in eastern Africa and quietly altered the evolutionary trajectory of our lineage. This species, later named Homo habilis, did not look human in any modern sense, but it introduced something entirely new: the deliberate modification of the environment through tools. The name Homo habilis, meaning handyman, reflects a defining innovation rather than physical appearance. Unlike earlier Australopithecines, which relied mostly on anatomical adaptations such as powerful jaws and large teeth, this species began using simple stone tools to access food in ways no hominin had done before. This shift marked a fundamental transition. Survival was no longer based only on teeth, muscle, or instinct, but on problem-solving, manual precision, and basic planning. The emergence of Homo habilis coincided with a period of intense environmental instability in Africa. Climate fluctuations reshaped landscapes repeatedly, transforming dense woodlands into open savannas and fragmented habitats. These changes placed enormous pressure on hominin populations. Many species disappeared entirely. Others survived only by adapting quickly. Homo habilis appeared during this unstable window, suggesting that flexibility, not specialization, became the key to persistence. Before we dive in, comment where you're watching from and subscribe to Primal Roots. The earliest fossils attributed to this species were uncovered in Olduvai Gorge, Tanzania, during excavations led by Mary Leakey in the early 1960s. Fragmented jaws, teeth, and cranial pieces revealed a combination of traits that did not fit neatly into existing categories. The brain case was larger than that of Australopithecines, yet still small compared to later members of the genus Homo. Facial features remained primitive, while dental reduction hinted at dietary changes already underway. These discoveries forced researchers to rethink where the human story truly begins. Subsequent finds in Kenya and Ethiopia confirmed that Homo habilis was not an isolated population. Instead, it occupied a broad range across eastern Africa, favoring environments near rivers, lakes, and mixed landscapes, where open grasslands met wooded areas. This geographic spread suggests an opportunistic species capable of exploiting varied resources, rather than relying on a narrow ecological niche. Such adaptability may explain why Homo habilis endured, while other hominins with more rigid diets struggled. One of the most significant breakthroughs associated with Homo habilis is the appearance of Oldowan stone tools. These tools were simple flakes produced by striking one stone against another, yet their impact was revolutionary. Sharp edges allowed early humans to cut meat, scrape hides, and break bones to extract marrow. This access to high-energy food sources dramatically changed nutritional intake. Animal fat and protein provided more calories than most plant foods, supporting increased metabolic demands and eventually brain expansion. There is no evidence that Homo habilis actively hunted large animals. Instead, cut marks on fossilized bones suggest a scavenging strategy. These hominins likely arrived at carcasses left behind by large predators, sometimes competing directly with hyenas and big cats. In some cases, they may have driven off smaller scavengers to access remains quickly. Timing mattered. Reaching a carcass early meant access to soft tissue and marrow before decay or competition made it unusable. The physical form of Homo habilis reflects this transitional lifestyle. The body combined traits suited for both ground travel and climbing. Arms remained relatively long, indicating that trees still played a role in daily life, possibly for protection or resting. At the same time, leg structure and foot anatomy show clear adaptations for efficient bipedal walking. This dual strategy allowed movement across open terrain while retaining escape options in predator-rich environments. The hands of Homo habilis reveal one of its most important evolutionary shifts. Shorter fingers and stronger thumbs improved grip strength and fine motor control. These features made precise manipulation possible, supporting repeated tool use rather than occasional opportunistic actions. Tool production itself required more than strength. It demanded selecting suitable stone, controlling impact angles, and repeating motions consistently. Such behavior implies memory, coordination, and basic learning processes shared within groups. Dietary evidence reinforces the idea of behavioral change. Compared to earlier hominins, Homo habilis shows reduced molars and lighter jaws, suggesting less reliance on heavy chewing. Processed foods, whether cut plant material or meat, reduced the need for massive teeth. This dietary flexibility would have been a major advantage during periods of resource scarcity, allowing survival when preferred foods were unavailable. The presence of Homo habilis alongside other hominins adds another layer of complexity. During the same time period, Eastern Africa was home to Paranthropus boisei, a species with massive jaws and teeth adapted for tough vegetation. The contrast between these two strategies is striking. While Paranthropus invested in extreme anatomical specialization, Homo habilis relied on behavioral innovation. Environmental shifts eventually favored flexibility over specialization, contributing to the disappearance of robust forms, while tool-using lineages continued. From the beginning, the classification of Homo habilis has been controversial. Fossils attributed to the species vary significantly in facial structure, brain size, and dental proportions. Some researchers argue that these differences represent more than simple variation and may indicate multiple species grouped under a single name. Others propose separating certain fossils into Homo rudolfensis. This debate highlights a crucial reality of human evolution. It was not a straight line, but a branching network of experiments, many of which left no descendants. Despite these uncertainties, Homo habilis holds a critical position in evolutionary history. It represents the earliest clear link between increased brain capacity, manual dexterity, and technological behavior. Even if it was not the direct ancestor of later species such as Homo erectus, it demonstrates that the foundations of human adaptability were already forming. By the time Homo habilis disappears from the fossil record, new hominins with larger bodies and more advanced tools were emerging. Yet the legacy of this early species remained embedded in the evolutionary path that followed. The simple act of shaping stone marked the moment when survival became increasingly shaped by intelligence rather than anatomy alone. The disappearance of Homo habilis from the fossil record did not occur as a sudden event, but unfolded gradually within a complex web of environmental change, biological competition, and evolutionary experimentation. During the late Pliocene and early Pleistocene, African ecosystems continued to fluctuate under shifting climate patterns. Periods of aridity expanded open landscapes, while shorter humid phases altered vegetation and resource distribution. These oscillations created unstable conditions that favored species capable of rapid adjustment and penalized those with limited adaptive range. Homo habilis occupied an intermediate position within this dynamic context. Its behavioral flexibility and tool use provided advantages over more anatomically specialized hominins, yet these innovations were still relatively limited when compared to later members of the genus Homo. As ecological pressures intensified, small differences in efficiency began to matter. Slight improvements in endurance, food processing, and spatial mobility increasingly determined which populations persisted. One of the most significant factors influencing the decline of Homo habilis was the emergence of more advanced hominins within the same geographic regions. Fossil evidence indicates temporal overlap with early Homo erectus, a species characterized by a taller body, longer legs, and a more energy-efficient form of locomotion. These traits allowed Homo erectus to travel greater distances with lower energetic cost, expanding its range and increasing access to scattered resources. Over time, this advantage likely reduced the ecological space available to earlier species. Technological differences further widened this gap. While Homo habilis relied primarily on older tools, later hominins began developing more refined stone technologies that improved cutting efficiency and durability. These advances enhanced carcass processing, plant preparation, and resource transport. In competitive environments, even incremental improvements in tool performance could translate into higher survival rates and reproductive success. Fire, although not part of the behavioral repertoire of Homo habilis, became a transformative force for later hominins. Controlled use of fire enabled cooking, which increased caloric absorption and reduced exposure to pathogens. It also extended daily activity into nighttime hours and provided protection against predators. Species that mastered fire gained an advantage that fundamentally altered survival strategies, further marginalizing hominins that lacked this capability. Population structure also played a critical role. Archaeological patterns suggest that Homo habilis lived in relatively small dispersed groups. While this reduced internal competition, it increased vulnerability to environmental disruptions. Small populations are more susceptible to genetic drift, disease, and sudden resource shortages. Recovery from ecological stress becomes increasingly difficult when numbers are low and territories fragmented. Predation pressure remained a constant threat. Large carnivores dominated African ecosystems during this period, and Homo habilis lacked physical traits for direct defense. Although bipedal mobility and climbing ability offered escape options, these strategies were not always sufficient. Evidence of carnivore tooth marks on hominin bones indicates that predation was a recurring cause of mortality. Over time, cumulative losses may have further reduced already limited populations. Despite its disappearance, Homo habilis continues to occupy a central position in paleoanthropological research, largely due to unresolved questions surrounding its classification. The fossil material attributed to this species displays considerable variation in cranial shape, facial structure, and brain size. Some specimens exhibit broader faces and larger molars, while others show more gracile features. This diversity has fueled debate over whether Homo habilis represents a single species or a grouping of multiple closely related lineages. Several researchers propose dividing the material into distinct species, often assigning certain fossils to Homo rudolfensis. Others argue that the observed variation falls within the expected range for a single geographically widespread species. These disagreements highlight the limitations of the fossil record, where fragmentary remains must serve as the basis for reconstructing entire populations and behaviors. The evolutionary position of Homo habilis remains equally contested. For much of the 20th century, it was viewed as the direct ancestor of Homo erectus. More recent analyses challenge this linear model, suggesting that both species may have evolved from an earlier, yet unidentified ancestral population. If this interpretation is correct, Homo habilis represents a side branch rather than a direct line of descent. Even so, its significance remains undiminished. What distinguishes Homo habilis is not its role as a universal ancestor, but its demonstration that technological behavior emerged early and independently of later evolutionary success. Tool use was not exclusive to the lineage that eventually spread beyond Africa. Instead, it appeared as a recurring solution among hominins facing similar environmental challenges. This insight reshapes how evolutionary progress is understood, emphasizing experimentation rather than inevitability. Modern research methods have significantly expanded understanding of this species. High-resolution imaging, digital reconstruction, and microware analysis allow scientists to examine fossil surfaces in unprecedented detail. Chemical traces preserved in dental enamel provide clues about diet, while internal cranial structures offer insights into brain organization. These techniques reveal aspects of daily life that were previously inaccessible, moving beyond basic measurements toward functional interpretation. Despite technological advances, many aspects of Homo habilis behavior remain unknown. There is no clear evidence of symbolic expression, ritual activity, or structured language. Communication likely relied on simple vocalizations and gestures sufficient for coordination, but limited in complexity. Social bonds probably centered on immediate survival needs rather than long-term cultural traditions. Mobility patterns also remain speculative. Seasonal movement between resource-rich areas is plausible, but the extent of territorial range is unclear. Without fire or advanced shelter construction, exposure to environmental extremes likely constrained movement. These limitations shaped the boundaries within which Homo habilis could operate, influencing both survival and evolutionary potential. The legacy of Homo habilis lies in its role as a threshold species. It marks the point at which biological evolution and technological behavior became inseparably linked. Tools extended physical capabilities, compensating for weaknesses and expanding ecological reach. This shift altered selective pressures, favoring cognitive flexibility over purely anatomical specialization. The increased availability of high-energy food initiated a feedback loop between nutrition and brain development. Although modest in scale, this process laid the foundation for the dramatic neurological expansion observed in later hominins. The evolutionary pathway toward larger brains, complex societies, and global dispersal begins not with dominance, but with adaptation under constraint. Extinction does not erase influence. While Homo habilis vanished as a distinct species, the behaviors it introduced persisted, refined and amplified by its successors. Stone tools became more sophisticated, cooperation more structured, and environmental manipulation more deliberate. Each step built upon earlier innovations, many of which first appeared in rudimentary form during this early phase. The study of Homo habilis underscores a broader lesson in human evolution. Progress is not linear, and success is not guaranteed. Multiple hominin species experimented with different solutions to survival, and only some endured. What remains in the fossil record is not a single path, but a record of variation, resilience, and repeated adaptation. Through fragmented bones and simple stone flakes, Homo habilis offers insight into a moment when intelligence began reshaping survival strategies. Its story is not one of dominance, but of transition. In navigating unstable environments with limited tools and modest cognitive resources, this species helped establish the foundation upon which later human evolution was built. Stay connected for the next chapters in this series, where the latest discoveries continue to reshape our understanding of human origins.